If you pointed a telescope at the Boötes constellation and looked past the local stars, you should see thousands of glowing galaxies blooming like wildflowers in a meadow. You would find 330 million light-years of absolutely nothing. It is a spherical tomb so vast that if the Milky Way were positioned at its center, we wouldn't have known other galaxies existed until the 1960s. We are talking about a hole in the universe that shouldn't exist according to our current laws of physics. In the next 15 minutes, we are going to calculate why this emptiness is mathematically impossible, uncover the terrifying theory of an expanding Type 3 civilization harvesting entire star systems, and reveal the hidden structures that prove our map of the cosmos is fundamentally broken. To understand the scale of the Boötes Void, we first have to discard our human intuition for size. When we look up at the night sky, we see a chaotic scattering of lights, but step back far enough, and the universe looks like a sponge. This is the cosmic web, a network of filamentary threads composed of dark matter and gas that funnel galaxies into dense clusters. Between these threads lie voids, which are usually around 30 to 50 million light-years across. The Boötes Void, however, is a monstrous outlier. It is nearly 330 million light-years in diameter. To put that in perspective, our own massive Milky Way is only 100,000 light-years wide. You could fit approximately 2,000 Milky Ways side by side across the diameter of this void. It accounts for about 0.27% of the entire observable universe. If the average density of the universe were applied to a space this size, there should be at least 10,000 bright, shining galaxies inside it. When astronomers first probed this region in 1981, they found exactly 0. With our most advanced infrared and deep space surveys, we have only found about 60. This isn't just a quiet neighborhood. It is a cosmic desert where the laws of probability have gone to die. The discovery began with Robert Kirshner and his team, who were performing a redshift survey. Redshift is the cosmic equivalent of a Doppler effect. As the universe expands, light from distant objects stretches into longer, redder wavelengths. By measuring this, scientists can map the 3D structure of the universe. Kirshner expected a uniform distribution, a steady hum of galactic signals. Instead, the data showed a massive, terrifying silence. It was as if someone had taken a giant scoop out of the fabric of reality. This raised an immediate, uncomfortable question for cosmologists. How do you get that much nothing? The standard model of the universe, called lambda CDM, suggests that everything grew from tiny quantum fluctuations after the Big Bang. Gravity pulled matter together into the cosmic web, leaving behind voids as the matter migrated toward the filaments. But gravity is a slow worker. It takes billions of years for a small void to clear out. For a void the size of Boötes to form naturally through simple gravitational migration, the universe would have to be much older than 13.8 billion years. It is a chronological impossibility. Some theorists suggest that the Boötes Void isn't one single hole, but rather the result of several smaller voids merging together. Imagine soap bubbles in a sink. As two bubbles touch, the wall between them pops, creating one larger cavity. If this happened on a galactic scale, it could explain the sheer volume. Even this bubble merger theory struggles to explain why there are so few bridge galaxies left behind. When voids merge, they usually leave a trail of breadcrumbs, thin filaments of gas, and isolated stars. Boötes is hauntingly clean. This brings us to one of the most provocative and chilling explanations in modern astronomy: the Kardashev scale, proposed by Nikolai Kardashev in 1964. This scale measures a civilization's level of technological advancement based on the amount of energy they can harness. A Type 1 civilization uses all the energy available on its planet. A Type 2 harnesses the total energy of its host star, possibly using a Dyson sphere. A Type 3 civilization, however, would control the energy of its entire galaxy. If a civilization reached Type 3 status and began expanding, they would need an unimaginable amount of matter and energy. One way to acquire this would be to enclose stars and eventually entire solar systems within energy-harvesting shells. From the outside, these stars would simply vanish. Their light would be blocked, making the galaxy appear to fade into darkness. If a highly advanced species originated near the center of what is now the Boötes Void and expanded outward in all directions, they would effectively darken the region as they grew. Under this lens, the 10,000 missing galaxies aren't gone. They are just hidden behind the ultimate engineering project. While this sounds like science fiction, some astronomers take the search for Dyson spheres very seriously. We look for mid-infrared waste heat, which is the thermodynamic signature of a civilization capturing starlight. We haven't found a smoking gun in Boötes, but the sheer circularity and emptiness of the void remain the best accidental evidence we have for such a massive cosmic expansion. But if we move away from the extraterrestrial hypothesis, we find a different kind of terror in the physics of the void itself. The galaxies that do exist inside Boötes are strange. They are mostly lake-type spiral galaxies, and they are significantly more productive at forming stars than galaxies in the rest of the universe. It is as if life in the void is an elite competition. These galaxies are isolated by millions of light-years of empty space, yet they glow with an intensity that suggests they are gorging on what little gas is left in the vacuum. This isolation has led to the island universe theory on steroids. In a dense cluster like Virgo, galaxies are constantly bumping into each other, stripping gas and stalling star formation. In Boötes, the lack of neighbors means no interference. It is a pristine, lonely laboratory of evolution. One such galaxy, jokingly named the loneliest galaxy in the universe, sits in a pocket of space so empty that its nearest neighbor is over 80 million light-years away. The Andromeda Galaxy is only 2.5 million light-years from us. If you lived on a planet in that galaxy, the night sky would be a terrifying pitch-black abyss. You would see your own stars, and then nothingness. No smears of distant nebulae, no starry clusters, just a void that stretches further than your mind can grasp. This emptiness has profound implications for the fate of our universe. Voids are not just empty spaces, they are actually the primary drivers of the universe's expansion. While gravity pulls matter together, dark energy, the mysterious force pushing the universe apart, dominates in the voids. Because there is so little matter in the Boötes Void to provide a gravitational counterpole, dark energy has a free hand. Voids act like cosmic balloons, inflating and pushing the surrounding filaments of the cosmic web away. The Boötes Void is essentially a giant bubble of dark energy that is actively pushing the rest of the universe away from its center. If these voids continue to grow and merge, they will eventually tear the cosmic web apart. But there is a third possibility for why Boötes is so empty. And it involves something called warm dark matter. Most of our models are based on cold dark matter, which moves slowly and clumps easily. If dark matter is warm, it moves faster and resists clumping on smaller scales. This would prevent small galaxies from forming in the low-density regions of voids, while still allowing large clusters to form at the intersections of filaments. This would mean that the missing galaxies in Boötes never existed in the first place. The matter was there, but the conditions were never right for it to ignite into stars. This leads to the concept of dark galaxies, massive clouds of gas and dark matter that have the mass of a galaxy but contain no stars to light them up. If the Boötes Void is filled with 10,000 of these dark ghosts, It would change our entire understanding of how the universe is balanced. We would be living next to a graveyard of failed empires that never even began. The mystery deepens when we look at the cosmic microwave background radiation, or the CMB. This is the afterglow of the Big Bang. A map of the temperature fluctuations in the infant universe. When we look at the area of the sky corresponding to the Boötes Void, there is a curious lack of significant cold spots that should correlate with such a massive empty structure. This suggests that the void might have formed much later than we thought, or that it is being influenced by forces we don't yet have names for. This brings us back to the sheer scale of the anomaly. One outlier can be ignored, but an outlier the size of Boötes demands a rewrite of the textbooks. If the void is a natural structure, then our understanding of gravity and the age of the universe is slightly off. If it is a result of merging voids, then our fluid dynamics models for the early universe need adjustment. And if it is artificial, the result of a Type 3 civilization, then we are looking at the footprint of a godlike power that makes our entire history look like a blink in the dark. The Boötes Void serves as a humbling reminder of our place in the cosmos. We spend our lives focusing on the stuff of the universe, the stars, the planets, the solid matter, but the vast majority of reality is the space between. We are the anomalies, the rare clumps of dust in a desert of nothingness. The Boötes Void is the ultimate desert. It is a place that challenges the Copernican principle, which states that we aren't in a special place in the universe. If we were in the middle of Boötes, our perspective of the cosmos would be so limited that we might never have developed the physics necessary to understand the Big Bang or the expansion of space. We would be trapped in a small bubble of light, convinced that our single galaxy was the entirety of existence. The fact that we can even see the void and recognize it as a mystery is a testament to our position on the edge of a cosmic filament. We are looking across the canyon into a place where the lights have gone out. Whether those lights were never lit, were snuffed out by the expansion of space, or were harvested by a civilization untold millions of years ahead of us, the Boötes Void remains the most silent, and therefore the loudest, mystery in the sky. To solve it, we must look deeper into the infrared, hunt for the shadows of dark galaxies, and perhaps prepare ourselves for the reality that we are not the only ones looking out into the dark. If you find the vastness of the Boötes Void fascinating, you might want to look into the Great Attractor, another cosmic mystery that is currently pulling our entire galaxy toward an unknown point in space at 600 kilometers per second. Knowing how much is still hidden in the dark makes every discovery that much more significant. Subscribe to keep exploring the edges of the known universe with us. And leave a comment below if you lived in a galaxy in the center of the Boötes Void. Do you think your civilization would have ever discovered the rest of the universe?